Good morning, all of you. In this session, I'm going to explain about centroid of an C section and U section. In this session, I will explain how to locate the centroid or center of gravity of these three sections. Okay. Before going to the problems, first of all, you have to know the fundamental, that is the centroid of a rectangle. Let's consider a rectangle or a square lamina. Let B is the base of the rectangle, D is the depth or height of the rectangle. Okay. Now I am drawing the diagonal lines for locating the centroid of this rectangle. Okay. The centroid of a rectangle always lies at intersecting point of these two triangles. Okay. So this point is the centroid of an rectangle. Okay. So this centroid always lies at a distance of base by 2 and height by 2. Okay. So this is the position of a centroid or center of gravity of a rectangle. Now, by using these fundamentals, you can solve any type of rectangular sections. Okay. Now, this is the example problem number 1. Locate the centroid or center of gravity of the given C section. Okay. Yeah, this is a given diagram. Okay. Yeah, this base is 100 mm and this height is 20 mm and the total depth is 90 mm and the width of this upper section is 120 mm and the thickness of this flange is 10 mm and here the base or width of this middle section is 20 mm. Okay, first of all, you have to split the given section into 3 rectangles. Okay, first you have to split the given section into 3 rectangles. Okay, like this. This is a bottom rectangle. I consider this bottom rectangle as section 1. Okay, let B1 is the base of the rectangle 1 equal to 100 mm. D1 is the depth of the rectangle. Okay, now let's consider this rectangle. Okay, from here to here, you have to consider this height from here to here. Okay, so here the height of this second rectangle is 60 mm. Okay, the height of this second rectangle is 60 mm and the base is 20 mm. Okay, B2 equal to 20 mm and D2 equal to 60 mm. Okay, this one is base 2, base of a second rectangle. Okay, B2 equal to 20 mm and D2 equal to 60 mm. Okay, here B refers base, D refers depth. Okay, in similar way, you have to consider this upper rectangle as section 3. Okay, now B3, here D3 is the depth of the third rectangle, D3 equal to 10 mm and B3 is the base of this third rectangle, B3 equal to 120 mm. Okay, so here I consider the given C section as 3 rectangles. Okay, this is section 1, section 2, section 3. Okay, now you have to locate the individual centroids. Okay, for locating the individual centroids, you have to consider a reference x and y axis. Okay, here I consider x axis below the C section, bottom of the section, and here I consider y axis. Okay, so here this one is the origin. Okay, always you have to prefer origin at the lower left hand corner, it's best. Okay, B1 D1, here B1 D1 here this one is a rectangle, so the area of this bottom rectangle is a1 equal to b1 into d1 equal to 100 into 20. Okay, base b equal to 100 and depth d equal to 20. So 100 into 20 equal to 2000 mm square. And here this one is b2 and this one is d2. So the area for this second rectangle is a2. A2 equal to base into depth. Base equal to 20 and depth equal to 60. So 20 into 60 equal to 1200 mm square. And this one is depth d3 and this one is base 3. So area a3. Area of a top rectangle a3 equal to base into depth. Okay. Base equal to 120 and depth equal to 10. Okay. That value equal to 1200 mm square. So these are the individual areas. A1, A2, A3 are the individual areas. Whereas capital A equal to A1 plus A2 plus A3. Okay, is the total area of the C section. Total area of a C section equal to capital A equal to A1 plus A2 plus A3. Okay. Now I am considering the x-axis here. Let's consider a y-axis at the lower left corner. Okay, so this one is the origin. Now you have to locate the individual centroid. For locating the individual centroids, I am drawing the diagonal lines for locating the centroid. Okay. So here this intersecting point is the centroid of the bottom rectangle. Let's C1. C1 is the centroid of the bottom rectangle. Now x1 is the distance of centroid C1 from y-axis. Okay, from y-axis. Distance of centroid C1 from y-axis equal to x1. x1 equal to half of the base. Here b1 equal to 100 mm. So x1 equal to 50. In similar way, y1 is the distance of centroid C1 from x-axis. Okay, y1 is the distance of centroid C1 from x-axis equal to y1 equal to d1 by 2. d1 equal to 20, 20 by 2 equal to 10 mm. So y1 equal to 10 mm, x1 equal to 50 mm. Okay, so this is the position of a centroid of a bottom rectangle. Now I am locating the centroid of this second rectangle. So for that purpose, I am drawing the diagonal lines for locating the centroid C2. Okay, C2 is the centroid of a middle rectangle. Now x2 is the distance of a centroid C2 from y-axis. Okay, C2, sorry, x2 equal to b2 by 2. x2 is the distance of centroid C2 from y-axis. Okay, so here b2 equal to 20 mm. So 20 by 2 equal to 10 mm. So x2 equal to 10 mm. In similar way, y2 is the distance of centroid C2 from x-axis. Okay, y2 is the distance of centroid C2 from x-axis. Here y2 equal to depth of the bottom rectangle d1 plus half of the depth of the middle rectangle. Okay, d1 plus d2 by 2. In similar way, you have to locate the centroid of this upper rectangle. For that purpose, I am drawing the diagonal lines. Okay, now this intersecting point is centroid of the top rectangle. Okay, C3 is the centroid of a upper rectangle. Now x3 is the distance of centroid C3 from y-axis. Okay, x3 is the distance of centroid C3 from y-axis. x3 equal to base 3 by 2. Okay, base 3 equal to 120 mm. So 120 by 2 equal to 60 mm is equal to x3. In similar way, y3 is the distance of a centroid C3 from x-axis. Okay, C3 is the distance of a centroid from x-axis. Here y3 equal to depth of the bottom rectangle plus depth of the middle rectangle plus half of the depth of the top rectangle. Okay, so d1 plus d2 plus d3 by 2. Okay, now x1 equal to b1 by 2, b1 equal to 100 by 2 equal to 50 mm, and x2 equal to b2 by 2, b2 equal to 20 by 2 equal to 10 mm, x3 equal to b3 by 2, b3 equal to 120 mm, so 120 by 2 equal to 60 mm. So x1, x2, x3 are the distances of centroid c1, c2, c3 from y-axis. Okay. In similar way, y1 equal to d1 by 2, d1 equal to 20, 20 by 2 equal to 10 mm, and y2 equal to d1 plus d2 by 2 equal to 50 mm. Here d1 equal to 20 plus d2 equal to 60, 60 by 2 equal to 30, so 30 plus 20 equal to 50 mm. In similar way, y3 equal to d1 plus d2 plus d3 by 2, d1 equal to 20, d2 equal to 60, so 20 plus 60, 80, 80 plus 10 by 2 equal to 5, 85. Okay, y1, y2, y3 are the distances of centroids c1, c2, c3 from x-axis. Okay, now I am considering these values in tabular form. Okay, so here I consider section 1 as the bottom rectangle, section 2 as the middle rectangle, and section 3 as the top flange. Okay, these are the individual dimensions. b1 is the base, b is the base, d is the depth or height of the rectangle. Okay, a1, a2, a3 are the individual areas. x1, x2, x3 are the distances of centroids c1, c2, c3 from y-axis. Okay, y1, y2, y3 are the distances of centroids c1 and c2, c3 from x-axis. Okay, already we know that the xc is the distance of centroid of an entire section from y-axis. Okay, a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. Okay, xc is the distance of centroid of an entire c section from y-axis. That value equal to 41.81 mm. You have to substitute the value of x1, x2, x3, a1, a2, a3. Okay, here a1 equal to 2000, a2 equal to 1200, a3 equal to 1200 mm square. Okay, and x1 equal to 50, x2 equal to 10, x3 equal to 60. Okay, you have to substitute these values in this equation. After substituting these values, you can get the value of xc. Okay, xc equal to 41.81. In similar way, yc is the distance of a centroid of an entire section from x-axis. Okay, a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. Now you have to substitute these values a1, a2, a3, y1, y2, y3 in this equation. After substituting these values, you can get the value of yc. Yc equal to 41.36 mm. Okay. So this is the final answer for this case. Now I am showing the position of a centroid or center of gravity of C section. Here x, this one is the x-axis, this one is y-axis. Okay, you have to consider these two axes as a reference. Okay. Now C1 is the centroid of a bottom rectangle, C2 is the centroid of a middle rectangle, C3 is the centroid of a top rectangle. Okay, here C1, C2, C3 are the individual centroids. Okay, C1, C2, C3 are the individual centroids, whereas CZ is the centroid of an entire C section. Okay, so C1, C2, C3 are the individual centroids. Okay, but CZ is the centroid of an entire C section. XC is the distance of centroid CZ from y-axis. Okay, so XC is the distance of centroid CZ from y-axis. In similar way, YC is the distance of centroid CZ from x-axis. Okay, so this is the position of the centroid of an C section. Okay, this is the final position of centroid. Okay, this is the last step for this problem. Now coming to the another problem. Locate the centroid or center of gravity of the given U section or channel section. Okay, U section also known as a channel section. Now this is the given diagram. You have to locate the centroid of this section. First of all, the given U section is split up into three rectangles. First one is the bottom rectangle, this one is second rectangle, this one is third rectangle. Okay, first of all, the given section is split up into three rectangles. Okay, like this. This one is the section 1, B1 is the base, D1 is the depth. Okay, in similar way, I consider this rectangle as a section 2. B2 equal to 20 mm and D2 depth D2 equal to 60 mm. Okay, here the total depth is 80 mm. You have to subtract this 20 value from this value. Okay, so the depth or height of this second section is 60 mm. In similar way, you have to consider this section as section 3. B3 is the D3 equal to 60 mm is the depth of the rectangle, third rectangle, and B3 is the base. Okay, so these all are the individual dimensions. This one is section 1, this one is section 2, this one is section 3. Okay, B is the base, D is the depth. Okay, now I am considering the reference x-axis and y-axis at the lower left hand corner. Okay, so this is x-axis, this is y-axis, and this point is origin. Okay, here I consider the origin at the lower left hand corner. Okay, now the given entire U section lies in first quadrant. Okay, here the A1 is the area of a bottom rectangle. Area of a rectangle equal to base into depth. So B1 into D1. B1 into D1 equal to 100 into 20 equal to 2000 mm square. And here B2 equal 20 and D2 equal to 60 mm. So A2 equal to area of a second rectangle, base into depth. B2 into D2 equal to 20 into 60 equal to 1200 mm square. And area 3, here D3, this one is B3. So A3 is the area of a third rectangle. Okay, B3 and D3, 20 by 60 equal to 1200 mm square. A1, A2, A3 are the individual areas. Okay, now I am considering the reference x-axis and reference y-axis. Okay, now for locating the centroid, I am considering the diagonal lines. Now I am drawing the diagonal lines. Okay, this intersecting point indicates the centroid of this bottom rectangle. Okay, this intersecting point is the centroid of the bottom rectangle. C1 is the centroid. Okay, now x1 is the distance of centroid C1 from y-axis. Okay, this is the y-axis. So x1 is the distance of centroid C1 from y-axis. Okay, x1 equal to half of the base. Here the base is 100 mm. So B1 by 2 equal to 50 mm. Now in similar way, y1 is the distance of centroid C1 from x-axis. Okay, so that value equal to half of the depth, D1 by 2. Y1 equal to D1 by 2 equal to 20 by 2 equal to 10 mm. Okay, now I am drawing the diagonal lines for this second section for locating the centroid C2. Okay, this intersecting point is a centroid of second section. Okay, C2 is the centroid. Now I am drawing the diagonal lines for this rectangle for locating the third centroid C3. Okay, C1, C2, C3 are the individual centroids. Okay, C1, C2, C3 are the individual centroids, whereas CG is the centroid or center of gravity of an entire section. Okay, now x2 is the distance of centroid C2 from y-axis. X2 equal to half of the base, that value equal 20 by 2 equal 10 mm. In similar way, x3 is the distance of centroid C3 from y-axis. Okay, here the total base is 100 mm. So you have to subtract this distance. Okay, so B1 minus B3 by 2 is equal, that value equal to X3. Okay, 100 minus 10 mm, that value equal 90 mm is the distance of centroid C3 from y-axis. Okay, now here C1, sorry, C2, C3 or here C2, C3 are the individual centroids. Here Y2 and Y3 both are equal for C2 and C3. Okay, so Y2 and Y3 are the distance of centroid C2 and C3 from x-axis. That value equal to depth of bottom rectangle plus depth of this rectangle. Okay, D1 plus D2 by 2. X1 equal to B1 by 2. X2 equal to B2 by 2. X3 equal to B1 minus B3 by 2. Y1 equal to D1 by 2. Y2 equal to Y3 equal to 50 mm. Okay. Now I am considering these values in tabular form. Okay. So these are the individual dimensions. These are the individual areas. Already we know that XC and YC. XC is the distance of centroid of an entire section from y-axis. Okay. Now you have to substitute the value of x1, x2, x3, a1, a2, a3. After substituting these values, you can get the value of XC. XC equal to 50 mm. In similar way, YC is the distance of centroid of an entire section from x-axis. Okay. Now you have to substitute the value of A1, A2, A3, Y1, Y2, Y3. Okay, after substituting, you can get the value of YC. YC equal to 31.81. Okay. Now I am showing the position of centroid of an U section of a given section. Here x-axis, this one is y-axis, so this one is the origin. Okay, so C1 is the centroid of a bottom rectangle, C2 is the centroid of a left rectangle, C3 is the centroid of a right side rectangle. Okay, so C1, C2, C3 are the individual centroids, whereas CZ is the centroid of an entire U section. Okay, CG is the centroid of an entire C section or U section. Okay, now YC is the distance of centroid centroid or center of gravity CZ from x-axis. YC equal to 31.81 mm. In similar way, XC is the distance of centroid CZ from y-axis. Okay, that value XC equal to 50 mm. Okay. Now this is the final position of the centroid or center of gravity of a given U section. Okay, this is the final step. Now coming to the another problem. Locate the centroid or center of gravity of a given U section. Okay, the procedure is the same as the previous problem. Okay, now repeat the same procedure for this problem. First of all, the given section is split up into 3 rectangles. First one is bottom rectangle, B1. B1 is the base B1 equal to 100 mm. Depth D1, height or depth D1 equal to 20 mm. Okay. Now you have to consider this left side vertical rectangle as a section 2. Okay. B2 is the base of a second rectangle. D2 is the depth or height of a second rectangle. Now I am considering this vertical rectangle as a section 3. Okay. Here D3 is the height or depth of a third rectangle. D3 equal to 80 mm. Here the total depth is 100 mm. You have to subtract this value 20 mm. Okay, from 100. Now B3 is the base of a third rectangle. Base 3 equal to 30 mm. Okay. Now I am considering the x-axis and y-axis. So this is the origin. Okay. Here B1 equal to 100 mm, D1 equal to 20 mm. So the area of this rectangle is A1. A1 equal to B1 into D1 equal to 100 into 20. That value equal to 2000 mm square. Now this one is a second rectangle. B2 equal to 20, D2 equal to 60. So the area of this second rectangle is A2. A2 equal to B in base into depth. 20 by 60 equal to 1200 mm square. Now D3 equal to 80 mm and base 3 equal to 30 mm. So the area for this third rectangle is A3. A3 equal to base into depth 30 by 80 equal to 2400 mm square. Okay. A1, A2, A3 are the individual areas. The total area is equal to A1 plus A2 plus A3. Okay. Total area of an U section equal to A1 plus A2 plus A3. This is a reference x-axis. This is a reference y-axis. This one is origin. Okay. This given U section is an unsymmetrical section. Now I am drawing the diagonals for locating these individual centroids. Okay, this intersecting point is the centroid of a bottom rectangle. Okay, C1 is the centroid of a bottom rectangle. X1 is the distance of a centroid C1 from y-axis. X1 equal to B1 by 2, base by 2. In similar way, y1 equal to half of the depth. Y1 equal to D1 by 2. Okay. Now I am drawing the diagonals for this second section. Okay. Here C2 is the centroid of this second rectangle. X2 equal to half of the base. X2 is the distance of centroid C2 from y-axis. In similar way, y2 is the distance of a centroid C2 from x-axis. Y2 equal to depth of a bottom rectangle plus half of the depth of a second rectangle. Okay. Now I am drawing the diagonal lines for this third section for locating the centroid of this section. C3, let C3 is the centroid of a third rectangle. X3 is the distance of centroid C3 from y-axis. Okay. Now y3 is the distance of centroid C3 from x-axis. Okay, that value equal to the depth of a bottom rectangle plus half of the depth of a third rectangle. Okay. X1 equal to B1 by 2, X2 equal to B2 by 2, X3 equal to B1 minus B3 by 2. Okay. Y1 equal to D1 by 2, Y2 equal to D1 plus D2 by 2, Y3 equal to D1 plus D3 by 2. Okay. Now I am taking these values in tabular form. Okay. Here these are the individual dimensions. These are the individual areas. Now XC is the distance of a centroid of an entire U section from y-axis. XC equal to A1 X1 plus A2 X2 plus A3 X3 by A1 plus A2 plus A3. Okay. Now you have to substitute these values in this equation. After substituting these values, you can get the value of XC. XC equal to 56.42 mm. Okay. In similar way, YC is the distance of centroid of an entire U section from XX axis. Okay. yc equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. Okay, a1 plus a2 plus a3 is the total area. Okay, now you have to substitute these values in this equation. After substituting these values, you can get the value of yc equal to 40 mm. Okay, so xc and yc is the position of a centroid or center of gravity with respect to origin. Now I will show the position of centroid. This is the reference x-axis, this is the reference y-axis. So this point is origin. Okay, now C1 is the centroid of a bottom rectangle, C2 is the centroid of a left vertical rectangle, C3 is the centroid of a right side rectangle. Okay, where C1, C2, C3 are the individual centroids. Okay, C1, C2, C3 are the individual centroids. Whereas CZ is the centroid of an entire U section. Okay, CG is the centroid of an entire U section. C1, C2, C3 are the individual areas. Okay, CG is the centroid of an entire U section. Okay, now XC is the distance of centroid CG from y-axis. In similar way, YC is the distance of centroid CG from x-axis. Okay, XC and YC is the coordinate of the centroid. Okay, so this is the final answer for this problem. Okay, in next class, I will explain how to locate the centroid or center of gravity of an Z section and I section. Okay, in next class, I will explain how to locate the centroid of these two sections.